Welcome to this Actuarial Research Centre webinar on the use of big health and actuarial data for understanding longevity and morbidity. We're delighted that so many of you have joined us today. My name is Andrew Cairns and I'm Director of the Actuarial Research Centre, and I'll be acting as Chairman for this webinar. A few words of introduction to the ARC. The ARC is the Institute and Faculty of Actuaries network of actuarial researchers worldwide. Our aim is to bridge the gap between academia and actuarial practice by delivering world-class research that has practical relevance and impact. Our speakers today are Professor Elena Kulinskaya and Nigel Wright. Elena holds the Aviva Chair in Statistics at the University of East Anglia. Elena is the Principal Investigator for the Big Health Data Programme and leads a multidisciplinary team including staff from Aviva. Nigel currently works on risk analytics within Aviva with a focus on the life business, and his role within the research programme is to provide advice on the practical actuarial aspects of the research programme. Lastly, just before I hand over, just a few housekeeping points. So first of all, you can post questions for the speakers at any point, any time during the presentation. You don't need to wait until one of the two question and answer sessions that we have lined up. Secondly, there are some live polls that we have during the webinar, and if you want to see the results of those polls as they are racking up the votes, you need to vote yourselves in order to be able to see what those results are. And then lastly, people will often be asking, will the slides themselves be available after the webinar? And the answer is yes, that they will be available on the ARC website straight after the webinar. So without further ado, I'll now hand over to Elena to present the webinar.
Thank you, Andrew. Hello, everyone. I'm Elena Kulinskaya, and I'm the principal investigator on the research program on the use of big health and actuarial data for understanding longevity and morbidity, which was recently funded by Actuarial Research Center for 4 years, from 2016. This is actually a joint venture of two schools at the University of East Anglia, School of Computing Sciences and Norwich Medical School, and Aviva Life. We have a multidisciplinary team which includes a computer scientist, data miner, health economist, ex-GP and now health researcher, and also two Aviva staff, which are Nigel Wright, an actuary who is here with me now, and also Sarah Allen, who is senior data analyst from Aviva Life. This is the website of our research program, and you will be able to see up-to-date news and download various materials free of charge, including the open source software which we are planning to deliver, but which is not yet ready. The main objectives of our research program is to develop novel statistical and actuarial methods for modeling mortality, modeling trends in morbidity and uptake of various health interventions, assessing basis risk, evaluating longevity improvement based on big health and actuarial data, and finally, we are planning to develop software tools to forecast longevity risk of a book. We are going to use primary care data available from the so-called the Health Improvement Network, or SIN. SIN is the primary care data from United Kingdom, which covers about 6% of all general practices in the UK. We are going to work with a subset of the data, which includes all the patients born before 1960 and followed up to the 1st of January 2017. This includes 3.5 million of patients. We're also going to add whereas social economic status variables such as index of multiple deprivation and mosaic, and we also are planning to work with actuarial data. The first aim of our program is identification and quantification of the key factors affecting mortality and longevity. We intend to have a target list of between 3 to 5 conditions or health interventions. Among the health conditions, we are planning to look at stroke, diabetes, perhaps cancer, including health interventions such as statin prescriptions or perhaps new blood pressure targets. And of course, the lifestyle factors would include obesity and smoking, among others.
So that brings us to our first poll. The question we have for you is, where do you think the potential increases in longevity are going to come from? We've given you a few options there, and then at the bottom we've got other. So if you want to choose other, then please let us know via a question what you think this other condition might be that we should be looking at.
So just as a reminder in terms of the housekeeping points, that if you want to see the results of the webinar, the poll as it's progressing, then vote and vote early, and then you can see how the bar charts are moving up. So those of you that have voted, you'll see that there is an early leader, but if you haven't voted, then you won't know what that is. So vote quickly.
And of course, we did this webinar this morning as well, so we know what the answer is. We're just going to see if you can get it right.
So the votes seem to be coming in quite rapidly now. I think we're up to now about half of the people that are online at the moment. So we'll give it a few more seconds and then we'll move on. But at the moment, certainly, there's a clear leader in terms of the cancer as being the leading choice.
Yes. And in fact, no one's chosen other, so.
Okay, so I think that's a good and clear result. So I think if we'll move on to the next slide.
Thank you.
For each of these several conditions and health interventions, we intend to design a population-based cohort study using an appropriate subset of the SIN data. We intend mostly to use so-called case control design, where cases, for example, people who have had a heart attack, are matched to several, usually 3 to 5 controls from the same GP practice and of the same sex and age. This provides balanced and comparable cohorts of cases and controls and simplifies the study of comparatively rare conditions, such as, for example, myocardial infarction, which also only affects, say, about 6% of the population. The full list of relevant confounding variables will be established from medical literature, such as systematic reviews, and of course using the medical expertise within the team. We have Nick Steele to help us with that. And to account for interdependence patients from the same GP practice, we are going to use multi-level modeling and also multi-level multiple imputation if we have missing values. Our second aim is modeling of temporal changes in the factors affecting morbidity and mortality. Trends in the incidence of various conditions and in the uptake of medical interventions may be also obtained from the primary care data. And basically, especially when we're talking about a new medical intervention, it may happen that the patients in more deprived areas would be left behind, and so the uptake of novel interventions by the more affluent patients would deliver increase in the longevity gap between the most affluent and more deprived areas. To be able to ascertain an effect of longevity on the whole population, we need to understand this kind of effect. So we need to model the incidence of a particular condition or an uptake of particular intervention over time in parallel to modeling mortality.
So that brings us to our next poll. So the question is, how soon will the next new medical breakthrough affect period life expectancy? And options there from between 1 or 2 years to 10 or more years. So we're always looking for the next big medical breakthrough. And our question is, our thinking behind that is that even the most amazing breakthrough will take some time to feed through into increased life expectancies. We have some illustration of this in the next slide, where we're looking at people who've had myocardial infarction and the different treatments that have been given to those.
So we've just had a few people voting now, and of course with this question and with other questions, you're open to interpret the question in whatever way you feel, and of course the way you answer this might depend on how you voted in the first poll. But we've got a lot of votes coming in now. There's one, well, it's quite a close race. If you've already voted, you'll see that it's fairly close, but and if I recall correctly, it was a bit different from this morning, is it? Yeah. So we'll give it a few more seconds, and then, because it's quite close, so we don't want to call the final whistle quite yet, but yeah, so I think that's probably a fair point to close that particular poll. But we've got a reasonable winner in terms of percentage votes, but it's a close winner in terms of 6 to 10 years. So that's people taking a view that it will take quite a long time for the next breakthrough to really have its maximum impact.
Okay, so let's see why we want to study trends in the uptake of various health interventions. If you look at this slide, you can see here 4 age cohorts. So people in the first age cohort up to age 60 were having heart attack before the age of 60. Likewise here, people who have had heart attack under the age of 65, before 70 and before 75 years. Different lines on the slides are uptake of different interventions. For example, this black line is an uptake of statins. As you see, it started from practically zero in mid-90s and took a while to be widespreadly available, but now in, say, 2010, practically everyone who have had a heart attack would have been prescribed statins. The same applies to aspirin, the red line, starting from about 50% going up to almost 100% by 2010. But other treatments were much slower in take-up. For example, the blue line here is the beta blockers, and it's pretty well established fact and part of the guidelines that beta blockers should be prescribed to people who have had a heart attack. Nevertheless, you can see that in 2010, uptake of beta blockers is just about 60%, even though they could save up to 1 year in life expectancy. And coming to more expensive interventions, this sign line here is actually coronary revascularization. And you can see that even in 2010, even though this is well established and very beneficial intervention, only about 40% of patients are getting it. So let's see who is getting this particular intervention. This slide here once more looks at our 4 age cohorts, but we also subdivided the data by gender and by affluents in 5 quintiles. The first fact which sort of strikes you looking at this is that there is very clear linear relationship in the uptake of coronary revascularization by quintile of affluence. People in the most affluent subgroups are getting much more than people in the more deprived areas. And this holds true for all 4 age groups. Coming to gender, this is even more striking. You can see that males are getting almost twice as much coronary revascularization procedures as females, even though this procedure is equally beneficial to both genders. Finally, coming to age groups, you can see that there is more uptake in the older age groups. So looking at those 2 slides, I think now you can understand why we want to study uptake of various interventions and gender and social economic status differences in this uptake to be able to predict the population life expectancy.
Thank you. The third aim of the project is the evaluation of plausible scenarios in mortality trends due to particular medical advances or lifestyle changes on the population of insureds. So aim 1 will give survival differentials associated with medical conditions and different treatments. And aim 2 will give the incidence and prevalence of the treatments over time and by factors such as age and socioeconomic variables. So we can use these to look at scenarios based on a specific makeup of an insured or pensioner population and see how that will affect the life expectancies or the outcomes for a particular population that you might be interested in. And then on to aim 4, finally, it's to provide tools for forecasting longevity risk of a book. And that will comprise an R package and tools, manuals and teaching material available to the actuarial community, and more widely, it'll be open source available through the project website. Thank you.
Okay, so well, that brings us to the end of the first part of the webinar, which is the general introduction to the research programme, and then in the second part there will be a case study in terms of research that's already been carried out. But we now do have time for some questions from the audience, and we've already got a couple of questions, but I would very much encourage you to start typing on your keyboards now and put in a few more questions for this first session, and then we'll have further opportunity for questions at the end of the second part of the presentation. So the first question is, how would this research help us in predicting changes in life expectancy?
Well, so what we can see is from the research you'll be able to see changes in life expectancy from different treatments or different prevalence of conditions, how that's happened in the past. And you'll be able to see how that's differed by different subpopulations. You could be able to split it by socioeconomic groups or genders or by ages. And then you could use that and apply it to a different population. So if you're more interested in a particular age group or a particular socioeconomic groups, see how that would transfer across. And then you can look at things like, for example, later on we're talking about statin prescriptions. If guidelines on statin prescriptions changed, more people were taking statins, you could estimate what the implications for life expectancy would be at a population level, but also for the subpopulation that you might be interested in.
And Elena, do you want to add anything to that?
Yes. Mostly I wanted to say that we are all used to look at the population life expectancy from the life tables without any differentiation by particular subgroups of the population. But of course, when we are dealing with particular book, we are interested in much more fine distinctions which are applicable to this particular subgroup of people we are working with. And our research would help to make sense of these various health differentials.
Okay. Second question is, and it's come up in two parts, so I'll need to make sure I read this carefully. What has been the major medical breakthrough in recent years so far that has improved life expectancy the most, and for how many years? And then the question continues, is there an equivalent measure for improved healthy life expectancy? So we can sort of ask that question in two parts. So first of all, what do you think has been, in your knowledge, the biggest breakthrough in terms of its impact on life expectancy?
To be sincere, I suspect that statins, of which we are going to tell you next, may have been the most important breakthrough in life expectancy, but we'll tell you all about it very soon. As far as healthy life expectancy is concerned, I'm not really sure. I suspect that it may be smoking, but I don't have any evidence to support my opinion.
Yeah. I was going to say, well, it depends what you count as a medical breakthrough, because realizing that smoking is so bad for you is quite a breakthrough. So then when the population gradually stops smoking, then that's shown huge improvements in life expectancies.
The next question is, how can we model the impact of medical breakthroughs such as gene manipulation?
Well, so far we don't have that breakthrough yet. So the answer is no, we cannot. We cannot yet see any effect of it on our health data. I suspect that in 20 years' time we would be able to notice something, but not quite yet.
And I guess also it really depends on how the data records that, in terms of whether we can, from a statistical perspective, actually measure what the impact is.
Yes, of course.
Next question is, how long will we be able to see temporal trends among the younger lives in the age group, given the longitudinal nature of the data? Is this not an important area?
The issue is that when we are looking at longevity, we need to see those younger lives moving into their 80s or 90s before we can estimate their longevity. So it is quite a long gap from, time when they're young to the time when we can estimate various effects. So it's easier to work with older populations. That's why we're looking at the people who were born before 1960.
Although in the data set we'll have their history as well. We'll know what they were doing when they were younger, what conditions they maybe had. For example, if it's diabetes, then you would have some idea of how long they've had diabetes before you start kind of following them and seeing what their life expectancy is from that age.
Well, then, of course, there's a survivorship bias potentially, but it depends on whether how much of an impact that might have had.
Well, that's right, yes.
And then there's one last question at the moment. I mean, we can, if there's another question, we can still take that at the moment. But the question is, do the less expensive treatments show the same pattern of use by gender and deprivation level, or is the difference less extreme compared to expensive treatments?
I think there is a general lag in even health promotion, if you want. Stopping smoking, for example, or obesity, depending on social economic status. At the moment, I can't compare where the, say, gender differences are more pronounced, to be sincere.
And one last question, and then we'll move back to the case study. What are the main sources for big data?
You mean for health?
Yes, or yeah. Or,
I mean, there are quite a few data sets available for health and actuarial research, and primary care data is one of the very good sources of data, but there is also hospital admissions data. In principle, there should be social care data, but this is much less developed at the moment, unfortunately. And then, of course, there is really what is called big data these days, like wearables data and that kind of thing. But unfortunately, we don't have access to this data. And we are aware that some insurance companies do have access to this data, and it would be really very interesting to try to link various sources of data, such as health data and this kind of wearables data, to be able to have much better insight into longevity.
yes, I think that's a particular challenge, is to try to, for academic researchers to have some access to these more commercial data sets from fitness bands and things of that sort, because they're collecting that data on a daily basis, and
that would be really very interesting, and perhaps actuarial community may come together and resolve this issue.
Okay, well, I think we'll draw that particular question and answer session to a conclusion, but please, from the audience, if you want to ask any more questions, then type them in just as we're going through the case study. But I'll now hand back to Elena to do the second part of the webinar.
Okay, so we're going to talk about our case study into the use of statins and life expectancy. We're talking about cardiovascular disease, or CVD in short, which is a disease of the heart or blood vessels, and it includes, of course, heart attack and stroke. Those are the well-known risk factors for CVD. I won't go through this list, you are well aware of it. And basically, the cardiovascular disease is due to fatty plaque, which is accumulated on the walls of blood vessels leading to the heart and in the arteries, and the statins are meant to ameliorate this problem of blood flow to the heart. We are going to look here at the so-called primary prevention of CVD. This means looking at healthy people and try not to get them to acquire cardiovascular disease. National Institute of Health and Clinical Excellence, NICE, which is a UK body which commissions drugs and health interventions for NHS, recently has changed their guidelines on the use of statins. Previously, statins were recommended when someone had more than 20% risk of CVD in the next 10 years. But recently, this guideline was lowered to just 10% risk at 10 years. So that increased quite dramatically number of people eligible for statin prescription. These days, up to 17 million UK residents are eligible for statins, and it resulted in quite large outcry from health professionals and general public, who felt that this is a wide-scale medicalization of practically healthy population. So how do we decide who has a risk of 10 or 20% in the next 10 years of developing CVD? This is so-called QRisk2 website, and you can go on the website, fill your details, age, gender, postcode, various chronic medical conditions, your height and weight to calculate the BMI, and you will end up with your QRisk score at 10 years. And as I said, if you have a QRisk above 10%, you are eligible for statin prescription. This recommendation is based on the previous meta-analysis of existing 27 randomized clinical trials by so-called cholesterol treatment trialist collaboration. And that meta-analysis was published in Lancet back in 2015. They looked at various heart-related events, but to be sincere, their research on longevity was pretty flimsy. You can see that there is some reduction in hazard of mortality due to statins from this meta-analysis, but looking at particular risk groups, we don't see any significant results. Therefore, we wanted to see what is the survival benefit associated with statin prescription as primary prevention of cardiovascular disease for different risk groups at various ages in general population. And our results are published in this paper, which is available in the open access, and that's what I'm going to tell you about. So we have designed a population-based cohort study. We looked at 4 target ages: 60, 65, 70, and 75 years old. And we looked at all people born between 1920 and 1940 and followed up from 1987 to 2011. We didn't include patients who had a history of cardiovascular disease because we wanted to look at primary prevention only. And we used multiple imputation to fill missing data on BMI, smoking, and so on. We used Cox proportional hazards model with frailty on general practice. And basically, we have built up 12 models. We have 4 age cohorts, and we have 3 risk groups: low risk of cardiovascular disease, less than 10%, moderate, 10 to 19%, risk of cardiovascular events in the next 10 years. This is a group which is newly eligible for statins, and the high risk group, the risk of above 20%. You can see that our cohorts are quite large. Mostly they are about 200,000 patients. Only the youngest age group is a little bit smaller. We have quite a few deaths here. And what is very important is that we have very long follow-up, up to 24 years in the youngest age groups. Coming to the distribution of men and women across risk group, you can very clearly see that the males are at much higher risk of cardiovascular events than females. If we look, for example, at age 65, you can see that there are 40% of women at low risk, but no men at all. And when we look at age 70, you can see the distribution is almost reversed. 80% of women are in the moderate risk group, and 83% of men are in the high risk group. And of course, by age 75, there are just no men in the moderate risk group. This is our results. Adjusted for a number of variables, we look at 3 risk groups. This is low risk group, and you can see that there is no significant effect of statins at low risk group. But looking at the moderate risk group, those are the people who now are eligible to get statins. We can see that if we look at statin prescription before age 60, we don't see any reduction in hazard of mortality. Perhaps it may be even harmful to prescribe statins at this early age. Looking at 65, once more, there is no significant effect of statins on longevity here. But in older ages, starting from 70, we do see significant reduction in hazard ratio of mortality due to statins. The same applies to the higher risk group. Looking at age 60, we don't see any significant effect of statins, but starting from age 65, we do see quite significant mortality reduction due to statins. So the conclusion from our research is that the NICE guidelines need to be modified depending on the age.
Thank you, Elena. So on to the next poll. So our question is, by how much will the next medical breakthrough increase population life expectancy? So we've been looking at the impact of statins on an individual, and then in the next slides we'll estimate the implications of statin prescriptions on an overall population life expectancy.
So we've got a few choices here, so we'll yeah.
In part, this will depend on how imaginative you were about what the next medical breakthrough is. Clearly, if you're imaginative enough, it'll have a huge increase in your population life expectancy.
Yeah. So we've got a few votes coming through at the moment, and of course you all want to just take a few seconds just to think about what the breakthrough is, and of course you might be thinking back to the earlier questions during the webinar. So we've still got quite a lot of people to vote at the moment, so we need to give all of you plenty of time. Oh, and it suddenly jumped up on our monitor. So yeah, so we've got about 100 people voting, and there's certainly a clear preference there at the moment, and it's just a few more people voting, but so we'll give you a few more seconds for the last few people to have a chance at having a go. Yeah, so at the moment we've got quite a lot of people have voted, and we've got 1 to 2 years as the sort of clear preferred candidate in terms of the likely improvement in life expectancy.
Mm. So we'll be able to do an analysis of this and see how much more optimistic afternoon people are than morning people.
Or maybe the other way around, maybe after a hard day's work
that's right.
you become more pessimistic about these things.
Yes. So as promised, we're looking at translating a hazard of mortality to a period life expectancy, or a period life expectancy for a population. And to do that, we would convert an actual age to an effective age, comparing a person who wasn't taking statins with the effective age they would be if they were prescribed and taking statins, and then see how much longer their life expectancy is. And so this is what we've done here. So we're looking at different ages down the side, and then 2 different levels of the Q risk. So if you're at the moderate risk, or what we've called the moderate risk is the 10 to 19% Q risk, or the more than 20% risk. So you can see in the top left-hand side, at age 65, we were finding that there was no benefit on life expectancies for age 65 of taking the statins, and so you've got zeros across there. Whereas down on the bottom right-hand side, for higher risk people at age 75, that was reducing your effective age by almost 2 years, and that was increasing your life expectancy, depending on males or females, by 1.28 or 1.46 years. So then when you're transferring that to a population life expectancy, you can allow for the current and possible future prescription rates for statins, and you can look at the prescription rates as they've increased over time. You can look at the prescription rates in 2010 and see what would be an increase in the life expectancy if instead of the, say, 40% prescription rate of statins you had at a particular age group, if that increased to 100% statin prescription rate, how much you'd expect the population life expectancy to increase by. So here the calculations we've done, we can look at how much you think that statin prescriptions are increasing the life expectancy by at the current or the 2010 prescription rates. So for example, for men aged 70, based on the 2010 prescription rates, you'd expect that to be increasing the life expectancy by, say, 0.52 years. However, if rather than the 2010 prescription rates, if they were 100% take-up of statins for age 70 men, that would increase the life expectancy by 1.27 years. In fact, we've got figures there by gender and by age. In fact, we think that might be an underestimate, because here in this study we've just been looking at people with no previous history of coronary heart disease. That there'll also clearly be people who have already been already got the coronary heart disease at a particular age. It doesn't account for the fact that some people who are prescribed statins won't be able to, won't continue or won't be able to continue to take them. And now for our final poll. So, as well as statins, we've been thinking about other lifestyle conditions or medical conditions. Our question is, do you think that the medical and lifestyle advances may counteract the obesity epidemic? So at the same time as the medical advances are coming through, you'll have heard about the potential long-term implications of the obesity epidemic.
And I guess in thinking about this question, it's again up to the members of the audience to interpret what sorts of lifestyle advances that or changes that might be coming up in the future. So it's a simpler set of choices. So I think we're seeing that the voting is the numbers are going up just a little bit faster than the earlier polls. And for those of you that have voted, you'll see, well there was a clear favourite, but the no campaign is suddenly catching up. So, so there's just a few more people that still need to vote, but it's relatively close. But the surge in the no votes has subsided perhaps slightly, and we're now over 100, but 100 voters. Still quite tight, but we'll just have a few more seconds and then we can conclude. So that's
okay.
Okay.
So yeah, thank you for that. So that's the end of our formal presentation. We're on to questions and comments.
Right, so once again, at the moment we have 3 questions, but if we want to fill up the hour and not shortchange everybody, so we probably do need a few more questions to be posted before we conclude. So the first question is, how do you plan to include people who have a family history of getting coronary vascular disease into the statin case study? Or is that even possible to do?
Well, unfortunately, primary care data doesn't have any genetics in it. They do have a question about family history, but unfortunately it's not filled very well. So there is a lot of missing values. So I don't think it's very feasible to fill this very reliably from the primary care data, unfortunately.
Okay. And would there be any possibility to, say, with big data, and it would be a much bigger study, to try to match up family history records in some
I
sort of way?
would really love to have some genetics data, so we would be able to see particular genes responsible for cardiovascular disease, but at the moment we don't have the data.
The next question is that the approach that you're taking is quite different from the ones that are used in clinical trials. So would you expect as a result of that to be getting different results?
This is an interesting question, because so far we have looked at two possible health interventions. The first one was statins. As you have seen, we got similar answers to those from clinical trials, perhaps more fine. So we know now that there are also age effects, but more or less similar. But we also tried to look at lowering of blood pressure targets. A couple of years ago, there was a very interesting clinical trial called SPRINT published, and that trial looked at aggressive lowering of systolic blood pressure to 120. It was a large US clinical trial. And we decided to check whether we can reproduce the SPRINT results in the primary care data from the UK. So we designed a study based on the SIN data, and actually our findings were opposite to those of the SPRINT trial. We discovered that if patients who had the blood pressure drop to 120 actually had worse survival prospects than those who kept their blood pressure at 140, which was a bit of a disappointment. Also, they had much more renal side effects due to extra drug load, I suppose. So as you see, sometimes we find very different results from clinical trials and from observational data. We believe that observational data is much more representative of the population data and therefore may be of more interest, because clinical trials usually include pretty selective population of patients, and also, of course, they're very short term, so we can't really judge any longevity benefits from clinical trials.
Okay. How do the next question? So how do the results on statin effectiveness compare with the current NICE guidelines?
Well, they do compare with the NICE guidelines, because we found that prescription of statins at above 10% cardiovascular risk is beneficial, but only in older age groups, starting from 70, I think. Yeah.
Next question. How do you plan to analyze the big data to obtain the insights for it?
Well, big data is a very vague term which includes many different things to different people. So far in this project we're working with the primary care data, which is reasonably big. It includes data on 3.5 million patients, and of course those patients come to their GPs for many dozens of years. We have lots and lots of data on, say, blood tests, on various prescriptions, and so on and so on. So this is a reasonably big data set. Our approach is to try to design a very well balanced and unbiased observational study, usually based on case control design. Our main issue with any observational study is to try to not introduce various biases, such as selection biases and that kind of thing, into the study. So we're pretty careful about this. And of course, you also need to have pretty sophisticated statistical methods to be able to work with this kind of data.
Are you aware of any similar work being carried out overseas?
Actually, I think that we are very lucky in the UK, because we have such a good source of primary care data. I know that American data is much less detailed in that regard. So I think that actually it's a really valuable resource of data.
I'm not sure, Nigel, if you have any other
I think that comes from the way that the health service works in the UK with the general practitioner, where is your first point of call, and they'll be keeping an eye on you, overall your overall health, rather than going to specific specialists more quickly.
Yeah. I mean, I certainly from my perspective, I've done some work using Danish data, and it's a different system of recording, but I think they also have very detailed records, including records of doctors' visits. And but I have to say, I don't actually know myself whether the people have been doing similar studies to yours, but there's probably potential in some other countries. But it's an interesting question to look at whether there are similar things going on, but there's certainly probably plenty of opportunities. So the next question is there any specific reason that you selected the Cox proportional hazards model? Why not consider other models like generalized linear models, etc.?
Well, there are two parts to this question. I think the first is looking at the survival analysis methods. Why did we choose Cox proportional hazards model and not some parametric survival analysis model? And we could have done, but we were lucky so far that assumptions of Cox proportional hazards model were satisfied for our data. We did use time-dependent covariates wherever needed. So if we don't need any particular parametric model, then it's easier to use Cox model. Coming to generalized linear model, I am aware that a lot of insurance companies, for instance, are using, say, Poisson regression, and this is pretty well established and almost equivalent approach. But looking at various correlations, for example, across within general practices and between the same patient across different years, it's much more convenient from statistical point of view to use frailty terms with Cox model as opposed to, say, negative binomial models.
Are there significant regional variations in the results?
Unfortunately, we don't know, because the privacy considerations prevent us from knowing the postcode. So the only thing we know about the patients is a mosaic or, say, index of multiple deprivation. And we also roughly know it's east, west, south, that kind of thing, but we are not aware of any geographic location at all.
Okay. But you are able to use index of multiple deprivation as not geographical, but...
We have index of multiple deprivation in quintiles, and we also have mosaic, which is much more detailed if we want it.
Were there significant variations due to race or ethnicity?
We don't have that data on race at all, sorry.
Next question. So, are you feeding back interesting results from your research to the National Health Service so that they might improve treatments?
Yes, actually we do. We published 2 papers so far in medical journals, one on survival after myocardial infarction and the second one on statins. And actually our paper on survival after myocardial infarction, in particular on the role of beta blockers, was picked up by the Journal of Hospital Medicine, who have done a short article on this.
Next question is, and this is probably for both of you, so what are your next planned analyses?
We want to make our analysis on statins more sophisticated, so we're now looking at multi-state model, which also would reflect moves of patients from on statins, off statins kind of thing, people dropping prescription and then picking it up once more, making our estimates more precise. We also want to continue working with various important diseases such as stroke or diabetes.
Another question is, how do you allow for changes in lifestyle, such as stopping smoking, once someone is told that they are high risk and prescribed statins?
Well, we do have smoking, even though we have some missing values in smoking status, but we do take smoking into account in our models.
And if somebody stops smoking, is that also something that you're able to?
There are three categories in ex-smoker, smoker,
Right,
and current smoker, but unfortunately we don't have amount of smoking, for instance.
But if someone starts off as a smoker and then during the course of the trial or the period that you're observing that individual, if they change status,
we can use smoking as time-dependent variable, I suppose, but I can't say that smoking is recorded very well in SIN, unfortunately.
I think it's improved though with the quality outcomes framework, which is rewarding GPs for asking questions about smoking, about lifestyle, and then recording those answers in the GP records. So when that came along, and the GPs were being rewarded for asking these questions and having those conversations, the quality of the data, the coverage of the data has improved.
And we'll possibly make this the last question. So why do you think that taking statins at younger ages is having what appears to be a negative effect on observed longevity?
Well, I don't have a real answer to this, but I suspect that this may be to do with various side effects of statins. If you are taking statins for 30 years, perhaps you have more chance of developing side effects. So, yeah.
Right.
And I think this is maybe one of the things where you can compare the study that we've done here with a clinical trial, where a clinical trial will be looking over a shorter term, and maybe rather than looking at mortality or all-cause mortality, we'll be looking at, well, either tracking the cholesterol readings or the incidence of heart disease or deaths from heart disease, rather than looking over a longer period and looking for all-cause mortality.
Okay, so before I round things up, so we have just a brief summary.
So finally, to go to our summary is, so to establish the drivers of changes in longevity and to predict how they may change over time, we need to incorporate health-related trends and advances. Clinical trials deal with a selective population of patients and usually are over a short duration. Also, they're rarely interested in all-cause mortality. We need to use individual level health data found in large health databases and to use sophisticated tools for modelling the mortality experience of participating populations. This involves resolving numerous ethical issues and also requires some time lag to be able to obtain sufficient population-based data.
Okay, so well, it just brings me round to the sort of concluding remarks. So first of all, I would like to thank you very much to Elena and Nigel for your presentation this afternoon, and then also to the audience, for joining us, and also for the questions that you've put, and also for participating enthusiastically in the polls. Now, this was the second out of the 3 Actuarial Research Centre webinars. The third one is tomorrow at both 9 o'clock and 5 o'clock, and that will be by Professor Jens Perk Nielsen, and he'll be talking about his pensions-related research. So with that, thank you and good night.